Greetings, it's Joel Duff. Welcome back to my channel. Really quick episode of Critiquing Creationism today. I'm a real big Iceland buff. I've been watching the volcanoes on Iceland over the past 4 years. And so I'm always keeping track of what's happening there. And one thing that I thought about a lot of times when I watch these volcanoes is I think about how long would it take to form the entire island of Iceland given the volcanic eruptions we see today? Can we use the present processes to sort of understand past, history? And so I thought we'd do just a really brief exercise, some really simple math, and do a little estimate of how long it would take to form the island of Iceland. So my question is, a young Iceland? And you might be looking at this picture right here thinking, yeah, I mean, look at that. That's brand new lava. And in fact, it is. That's a picture just taken a few days ago. But overall, no, it's young, relatively speaking, compared to a lot of other continents. It's a newcomer, but is it 4,350 years old? I'd say nah to that. But rather, is it a Forn Eyja? Oh, yeah. Let's talk about that coming up next. So they're on the Reykjavik Peninsula near the town of Grindavik, which is on the shore. And this, in fact, some of the lava has actually penetrated into that little hamlet once. And it's been in constant danger, especially over this past year. So here's a photo from just a day ago showing the current eruption, which continues. I think we're on to like day 30 or something like that. Just constant, eruption, constant using of this lava out, and it's been spreading out across the surface. And any of that's kind of impressive. It looks pretty impressive. It's like, yeah, that's most of that black stuff you see in this picture is brand new lava, 30 days old or less, right? So that's really young stuff. Like Iceland is growing, it's increasing in its volume as a result of this. And of course, there are many other volcanoes on Iceland that have erupted at various points in the actually known historical eruptions. And so we know that it's a very active place. Iceland is where it is cut right through the middle by the plate boundaries, and there's spreading going on there. So it's being pulled apart, magma is oozing up through that crack and then spreading out onto the surface in some places. And so here we have this production of magmatic material. But what I want to draw your attention to in this particular picture is those mountains in the background, right? That little volcano that you're seeing right there is about getting close to about 100 feet tall altogether, right? That's maybe 300 feet wide, right? The length of a football field, right, is that cone. And then that lava spreading out there has covered several kilometers, right, square kilometers of land. But as I look at this, when I think about it, when I ponder the origins of Iceland, and I see images like this area is a huge valley, and this whole valley is being, there's a new layer of lava being laid out in it. This is one of the reasons why the current eruption isn't terribly threatening to anybody, because this is an uninhabited area and there's a very large area to fill. All right, so this thing's going to have to go on for 6 months to a year in order to flow out of this valley and potentially impact other people. Now, there's a lot of concern about other cracks opening closer to the village of Grindavik, and also some other power plant that's nearby as well. But this area, pretty much just letting it go, right? It just is spreading out, gradually filling this particular area. But there's mountains all the way around. Here's another shot here. You'll see here's some huge hills. In fact, over the top of those hills off in the distance is the eruption from a different location from 2000, I think it was 2020 or 2021, which then erupted sort of higher up on behind those hills. And it actually flowed down over the side of the hill, down into the valley, and began to fill that particular valley before the eruption subsided. And so there's only so much sort of magma in the chambers that are below this. And then they build up pressure, and then that pressure is released when it finally finds a crack and pushes its way out onto the surface. But eventually, the pressure from the below subsides because of the release of that pressure. And then the flow slows to a point where it then solidifies, plugs up the gap again, and then you have to wait until that pressure builds up again. And so this is an iterative process. There's not going to be like all kinds of volcanoes going on at the same time typically. It sort of takes turns because they're all tapping from some primal source very deep in the hot spot that's below this particular region. All right, so let's just think about these huge mountains. All right, they're not huge mountains, but nonetheless, they're 500 to 1,000 feet tall in some places in this particular area. So this represents all volcanic material, right? I mean, I don't think I have to convince you that Iceland is an entirely volcanic in origin. Like the Hawaiian Islands, right, are all volcanic in origin, but Iceland completely dwarfs the size of the Hawaiian Islands. And so it allows us to ask question, or allows me to ask the question, like, how long would it take to have made all these mountains? All these mountains are volcanic. And so now let's put ourselves in the mindset of let's say a young age creationist who is trying to explain the origin of Iceland from the perspective of a young age, all right, that the world is only 6,000 years old. Is Iceland the product of God's original creation in the young age creationist mind? No, not at all, because it has no flood sediments on it, right? Noah's flood didn't deposit any sediments, right? Oceanic or terrestrial sediments that are not volcanic in nature, right? These are completely volcanic islands with no evidence of any other deposition. And so it doesn't appear they were covered by Noah's flood, but Noah's flood was global, and therefore they would argue that Iceland is formed after the flood. Well, the flood occurred 4,350 years ago, give or take a couple years or so in those models. And therefore, the entire island of Iceland has to be 4,350 years or less in terms of its age. Now, some of it's much less, like in this picture right here, you've got brand new lava. Yes, that's less than 4,000 years old. But what about those hills in the distance? Young Earth creation say, like, they have to be somewhere under 4,500 years old. That is an enormous production of volcanic material. It's an enormous production of heat that must be dissipated from this. Some of the lava flows from 4 years ago are still hot, all right, inside from where and even though they're only 30 feet, thick or so. Imagine these entire mountains, right, being produced, and the time it would take for it to dissipate all that heat, much less the sulfur that's going to be emitted from these volcanoes. That's one of the dangerous things about the current eruption, and why there's not so many visitors to it, is because it's considered to be a little more volatile in terms of the gases that are coming out of there. And so if the wind blows the wrong way in the wrong place, you can really hurt yourself around this particular volcano. But anyway, what about, so let's think about the total surface area. See, it's kind of impressive when you look at a picture like this. You're like, oh yeah, see, it's covering that area. If you just had this happening every year, right, for 4,000 years, I think you could talk yourself into maybe, oh yeah, you could produce a giant mound of lava over that amount of time. Maybe that could make the entire island of Iceland. But I want to give you a little perspective. All right. In this drawing, what we have with these different colors is showing you the lava that has been spread out from 2021, 2022, and then eventually here in 2023, we had several eruptions. And then now in 2024, we have the current eruption, which is this red stuff here, starting in February 8th. All right, February into March, with April now, so it's actually more than 30 days with the current eruption. And then in January, there was a crack that opened up all the way down into the city of Grindavik, and a small amount of magma came out there. And fortunately, the pressure was subsided very, very quickly, and not so much. There was not enough to really do a great amount of damage to the city. I mean, there was like a couple buildings that were destroyed from that. All right, so yeah, that's kind of an impressive amount of total square coverage, several square kilometers of new magma has been deposited in Iceland over the past 4 years. But all of this over here is just all on the Reykjavik Peninsula. And it's just on one small little area, right? This detail is this little section you're seeing here is just where this dot is right here. Well, so Iceland's a pretty darn big place. And we've just put a little bit of magma out on the surface on one little small portion of Iceland. So I started thinking about, this is just something that popped in my mind as I'm watching these videos, about Iceland. And I'm seeing all these hills, and I'm just thinking, like, when were they made? Like, you could do radiometric dating on them and so forth and get some dates, but let's just do some back of the envelope type of calculations. Let's try to think about what's the total volume. What's the total volume of basalts that are on that make up Iceland? So I looked up the total surface area, right, of Iceland. So it's 103,000 square kilometers. So roughly the size of Colorado. All right, so the size of Colorado is this island. The average elevation for the whole island averaged out 500 meters, right? 500 meters. So think of that as a little over 1,000 feet. That tells you there's some pretty darn big, mountains on Iceland, all right? Because a lot of Iceland is also not very much above sea level as well, right? So for it to average over 1,000 feet high for that entire 103,000 square kilometers, all right, it's a lot of magma. So that is 50,000 cubic kilometers. 50,000 cubic kilometers, kilometer each side of that cube. All that material is above sea level. Right, so we have to account for 50,000 cubic kilometers of material having been extruded, all right, from deep down in the mantle onto the surface of the Earth. Eruptions, to give you an idea of like the volume here, the eruptions from 2020 to 2023, the recent series of eruptions on the Reykjavik Peninsula have produced about 1/15 of a cubic kilometer. 1/15 of a cubic kilometer of basalt. All right, that's 70 million cubic meters. Now, when you say it that way, 70 million cubic meters, it sounds like just a huge amount. But put it in kilometers, there's like 1/15 of a cubic kilometer. So 1/15 is of 1/15 of a cubic kilometer is a whole lot less than 50,000 cubic kilometers. I'd also done some calculations to see like what would be like how long would it take at the present rate of magma production, all right, on the surface. And if you take like over this last 4 years, how much has been produced, get some sort of average per year, and then you ask yourself how long would it how long would it take you to make 50,000 cubic kilometers, right? It was well in excess of a couple million years. Now that's actually probably a lot less time than the actual age of Iceland, especially from radiometric dating. We know it's probably a bit older. And also that rate averaged over the last 4 years is probably a high rate, right? So in terms of the total amount of new material being added to Iceland over the last 4 years, it's a pretty active time for Iceland. And we have records for the last 1,500 years of events that have occurred in Iceland. And we know of various lava flows in various places. And there's been calculations of the total amount of new production of material that have been added to Iceland over different times. And it's gone in little spurts, right? There's been active times for a decade, 2 decades or so. They think right now the Reykjavik Peninsula is sort of firing up, and they might be in for another 15, 20 years of just sort of like these eruptions occurring every couple months or maybe every year. But if you average out over that 1,500 years, what's happened in the last couple of years is actually a fairly high rate, right? So taking a lower rate, you're going to get, of course, assuming sort of consistency over a long period of time, you're going to get millions and millions of years in order to produce 50,000 kilometers, 50,000 cubic kilometers of material. Right. So now, fair enough. I mean, I'm sure young age creationists are going to balk at using the present processes to extrapolate into the past and say, well, it could have been much higher in the past. Well, of course, if it's only going to be 4,500 years ago, it has got to be a whole lot faster in the past, right? It has to have just been flowing out all over the place, like at all places around Iceland all at the same time. And the fact that there's different sort of types of mountains and they have experienced different amounts of erosion and so forth doesn't suggest it was all produced all at one time. It suggests a series of historical events, right, where you have overlapping layers of lava, magma on the surface, but you also have thick ash layers because you also have explosive volcanoes in other parts of Iceland. Fortunately, on the Reykjavik Peninsula, not so much. So anyway, the idea is that it appears that Iceland has been built through a whole series of stages of iterative volcanoes, all right, at different intervals. And then what I'm not going to do, because I'm going to make this one short, I also am going to show in another video that there are soil layers between layers of lava, right, that have been deposited on the surface, suggesting that lava has been deposited, and then there's been a period of time to develop soil, and then more lava and so forth. So it's not an instantaneous process or a process that can occur over a very short period of time. All right, so, but I got to get to the rest of this story because we're just talking about the total volume and the challenge that is to young age creationists. Now, I've just been saying the total amount of the volume of material that's above sea level is 50,000 cubic kilometers. But now take a look at this Google Earth image, which shows you the ocean, all right, around Iceland. You'll see there's a very large continental shelf around Iceland. Okay, so sometimes I'm editing my videos and I'm just like, Joel, what were you thinking? What were you saying? Why did you use that particular term? This one was egregious enough that I decided I'm going to put this little addendum in, right? Make this little video short, squeeze it into this video just to say, like, yes, I know Iceland doesn't have a continental shelf since Iceland isn't a piece of a continent, right? Because I'm talking about this area underneath the sea that extends out from the island. So the island would be much larger if the ocean, the sea level, was about 500 feet lower than it is today. And so if you think of the continental shelf as kind of similar, like the continent extends out further as continental crust. This is not continental crust because Iceland isn't a continent. Nonetheless, I should have been just referencing the fact that this represents the total size of the area, the immense pedestal of volcanic material that sits on top of the oceanic crust, right? The deep ocean crust. And so this is the total area above that, right? So not a continental shelf. All right, back to your regularly scheduled programming. Right, and this continental shelf is, anywhere from just a few meters deep where the ocean is to, maybe 100 to 200 meters deep, and so it's fairly shallow, meaning that during past ice ages, when the water was much lower on Earth, the island actually was far larger than it is today. But the point is that all of this is volcanic material. Right, you can go down there and drill down into it. This is all volcanic material, same stuff that Iceland's made out of. And then there's a big drop off here to an average of well over 1,000 meters. All right, so deep ocean all around this. And so this represents one enormous island. And so now if we go and ask, like, what's the total amount of basalt that's sitting up on top of the plate, right? You got the oceanic plate, and then you've got this giant mound of volcanic material. All right. And so all of that has to be something that was deposited after the flood, because if the flood waters were still churning, you would have had tons of sediment in there, and you would have sediments falling out, and you would have had all these other sedimentary rocks that are not of volcanic origin. But you don't have that. So it's all post-flood. So that entire thing has to be 4,500 years or less. So there's a lot more volcanic material below the sea than there is visible above the sea. The average depth of the ocean off the Iceland shelf is, oh, I had said 1,000 meters before, I forgot, 2,000 meters. So if we take 200,000 square kilometers, I'm just saying, we're saying roughly twice the size. We said it's about 100,000 square kilometers for the mass here, for the island, right? But then if you look out here and you look at the edges of the continental shelf, I'm going to say that's roughly twice as much space, right? I'm trying to be generous with my, my conservative, my numbers here. So let's say 200,000 square kilometers times 1,000 meters, right? Again, I'm going to be really conservative here. Much of the ocean is more than 2,000 feet down to sort of the floor or the crust, right? But we'll just say, for sure, 1,000 meters, all right, thick from sea level down is all volcanic material. So that gives us 200,000 cubic kilometers, 200,000 cubic kilometers of volcanic material, all right? So eruptions over the past 1,000 years, right? Historical eruptions, we can go and they can figure out, like, this lava has been deposited or this ash has been deposited within the past 1,000 years, and we can actually tag that to known events, right, in historical records, may have produced up to 4 cubic kilometers of new material. So over 1,000 years, a 4 cubic kilometers of new material. That's only 1/50,000th of the total mass. Right? 1/50,000th of the total mass of Iceland. And so to suggest that Iceland is only 4,500 years ago, you're going to have to suggest that there was enormous volcanic material after the flood, producing virtually all of that island, right, in a very short time span, which again creates a heat problem. Right? You're heating. Well, at first you're heating the ocean a lot, a whole lot, and then eventually you're heating above the ocean, but you're also making an enormous amount of gas, right? Various volcanic gases at this particular time. All right, and it all has to solidify. It all has to have eroded. These mountains have eroded. Many of them that are extinct volcanoes have eroded to a great extent. You have to explain that particular erosion within a short period of time. And then in my next video, I'm going to talk about the fossil record of Iceland. Yes, to my surprise, there are fossils on Iceland, and they are preserved in volcanic sediments. And I was shocked to find out what some of the things that have been fossilized there. And it's a really, really interesting story. Just a teaser, all right? I'm not even going to tell you, like what I discovered about the fossil record there. But I was really fascinated by that. And so I'm still working that up. But, that's kind of the story, right? It's just like I look at places like this. It's kind of like going to the Grand Canyon and you stand there and you look at it, and it doesn't shout out to you, this is only 4,500 years old. No, it shouts out to you that this is the product of an enormous number of historical events, all right, and cumulative, therefore, have taken an enormous amount of time. And Iceland gets me that same feeling when I see the mountains off in the distance, and I recognize, especially since I've seen a lot of other pictures from the rest of Iceland, just the enormity of the amount of volcanic material that Iceland is made up of. So I think that's a really serious challenge to the young age hypothesis of the origin of the world around us. Iceland, it speaks of an ancient island, all right? An ancient island, not a young and youthful place, despite there being some young and youthful places on Iceland. After all, people have lived on parts of Iceland for well over 1,000 years and have not been terribly concerned about. Okay, yeah, let's just quit there. That's enough about my first story about Iceland geology. And like I said before, we'll talk Iceland fossils and paleontology maybe next time. All right. Talk to you later. Bye bye.